Have you ever wondered what would happen if you fell through the Earth? An intriguing question, isn't it? This is not just a random query, but a classic thought experiment in the realm of physics. But what, you might ask, is a thought experiment? Well, it's a hypothetical scenario that scientists use to explore the realms of the possible and the impossible. They help us to wrap our heads around concepts that are often too large, too small, too complex, or too dangerous to explore in real life. In this case, our thought experiment is about falling through the Earth. It's a question that has tickled the curiosity of scientists for generations. It's a fascinating blend of imagination and scientific principles, a journey into the unknown, guided by the laws of physics. Now let's dive into the science behind this intriguing question. Imagine for a moment that you've just started your journey to the center of the Earth. You're falling, plunging into the unknown, and the first thing you'll notice is gravity. As you descend deeper, gravity pulls you faster and faster towards the heart of our planet. But what exactly is happening? Well, let's break it down. As you fall, the force of gravity accelerates you, increasing your speed. You're essentially free falling, similar to a skydiver, but in this case, there's no parachute to slow you down. You're getting faster and faster, and as you do, you'll start to feel the effects of air resistance. Now, air resistance isn't something we often think about, but when you're hurtling towards the center of the Earth, it becomes a significant factor. The air molecules you're rushing past start to resist your movement, causing friction. This friction generates heat, and as you continue to fall, this heat builds up. Picture this: you're in a car driving at a high speed. As you stick your hand out of the window, you'll feel the air pushing against it. That's air resistance. Now imagine that, but on a much larger scale. Your entire body is experiencing this resistance, and the heat generated is not just a warm sensation, but a severe, intense heat. As you continue to plummet, this heat increases. It's like you're a meteor entering the Earth's atmosphere, burning brighter and hotter the faster you go. But unlike a meteor, you're not just passing through, you're going all the way to the core. Every second of your fall, the heat intensifies. The air resistance becomes stronger. The friction increases. It's a fiery, scorching journey, one that's filled with challenges and obstacles you'd never expect from a simple fall. But this is just the beginning of your journey. Let's explore what happens next. You've now reached the very center of the Earth. What do you experience? Imagine you're in the heart of the Earth, surrounded by a world that's as alien as it is hostile, a realm of unimaginable heat and pressure. This is the Earth's core, a place where our everyday rules of existence simply don't apply. The Earth's core is a blistering cauldron of molten metal, reaching temperatures of up to 5,400 degrees Celsius. That's as hot as the surface of the sun. To give you some perspective, that's about 1,000 times hotter than a typical kitchen oven at its highest setting. On top of the extreme heat, the pressure here is 3 million times greater than the atmospheric pressure at sea level. That's comparable to having 50 jumbo jets piled on top of you. Needless to say, you would be crushed and incinerated long before you reach this point. But what exactly is the Earth's core made of? Well, the core is split into two parts: the outer core, which borders the mantle, and the inner core. The boundary separating these regions is called the Bullen discontinuity. The outer core, about 2,000 kilometers or 1,200 miles thick, is mostly composed of liquid iron and nickel. The inner core, though smaller, is solid and made up of the same elements. Now, what makes the core so fascinating isn't just its extreme conditions or its composition, it's the role it plays in creating Earth's magnetic field. This magnetic field is generated by the movement of molten iron within the outer core. It's this field that creates a protective barrier around our planet, shielding us from harmful solar radiation. Without it, life as we know it would cease to exist. So, a trip to the Earth's core would be a one-way journey, but what if you could somehow survive? Let's find out. Congratulations, you've survived the journey to the Earth's core. What happens next? Well, now we're on the other side. Imagine you've just passed the halfway mark, the core, and you're now on your way up again. But there's a catch. As soon as you pass the Earth's core, gravity starts to pull you back towards it. Yes, that's right. The very force that initially pulled you down to the core is now acting as a brake, slowing you down as you try to move up and away from it. It's like a cosmic tug of war, with you in the middle. So what does this mean for our journey? Well, it means that as you approach the surface on the other side of the Earth, your speed decreases. You might think you'll pop out on the other side like a champagne cork, but instead you'll come to a stop just as you reach the surface, and then gravity will pull you back down towards the core again. This is what physicists refer to as oscillation. You'd become like a yo-yo moving back and forth along the same path through the Earth. You'd fall towards the core, slow down as you pass it, stop at the surface, then fall back towards the core again. The process would repeat, theoretically, forever. In this ideal world, you've become a human pendulum, oscillating back and forth. You've not only survived a journey to the Earth's core, but you're now trapped in an endless loop, forever falling through the Earth. But before you start worrying about this hypothetical eternity, let's pause for a moment, because while this is a fascinating thought experiment, there's one last thing we need to consider. So in an ideal world, you would be stuck in an endless loop falling back and forth through the Earth. But there's one last thing we need to consider. We've taken a fun and fascinating journey, but let's come back to reality for a moment. Our hypothetical journey through the Earth has been full of whimsy and wonder, but it's time to delve into the reality of this proposition. It's an exciting thought, isn't it? Falling right through the center of the Earth, experiencing the thrill of a lifetime. However, countless factors make this adventure not just improbable, but impossible. Let's start with the obvious: the heat and pressure. As we descend deeper into the Earth, the temperature increases. It gets hotter than a summer day in the Sahara. The pressure, too, is unimaginable, reaching levels thousands of times greater than what we experience on the surface. These conditions are far beyond what any human could survive. Next, consider the lack of oxygen. As we plunge deeper into the Earth, we would quickly run out of breathable air. Even if we somehow managed to withstand the extreme heat and pressure, suffocation would be a certain fate. Then there's the Earth's rotation. Our planet spins on its axis, and this rotation would have a significant impact on our journey. You see, if the Earth didn't rotate, we could theoretically fall straight down, but because it does, we'd be pushed to the side of our hypothetical tunnel long before we reach the center, like a marble spiraling down a drain. Lastly, we can't forget the Earth's composition. It's not a hollow sphere, but a solid mass composed of layers of rock, metal, and molten lava. Digging a tunnel through this would be a task of Herculean proportions, and keeping it open against the immense pressure and heat, an impossible feat. So, while it's a fun thought experiment, the reality is that you wouldn't want to take a trip through the Earth, but it's always fun to imagine, isn't it? So we've taken a journey to the center of the Earth and back, all in the name of science. We've delved into a fascinating thought experiment, exploring what would happen if we could pass straight through the Earth. We've ventured to the core, experienced the effects of gravity, and emerged on the other side. We've also faced reality, acknowledging the physical impossibilities of this journey, from the extreme heat and pressure to the fact that we'd need to be traveling at an impossible speed. But remember, this was a thought experiment, and such experiments are vital tools in physics. They help us explore concepts, challenge our understanding, and stimulate our curiosity, even when they defy the laws of nature. Thank you for joining me on this journey. I hope you've learned something new and had a bit of fun along the way. Until next time, keep asking questions and exploring the world around you.